right? Like what I highlight before. And the answer will always be the same, okay? So the first thing I'm going to do, I'm going to analyze from left to right, okay? So left to right, I'm only going to focus here. Okay. So down here, we know that we have 800 pounds. And then we have a CY. Our CY is 1640. And then at over here, we're gonna assume member AB, or moment, not member, moment AB. Moment AB, we do it that way because we are making a what? Positive bending moment assumption. Okay? We just assume that direction. Later on, when I show you from right to left, okay, what is the positive bending moment assumption? What direction? Okay. So now we are going to do summation about moment. Z at point AB location is equal to 0, right? So we are going to do our bending moment at point AB. By the way, I'm not going for a break, okay? I'm going all the way. So if you guys need a break, you guys go. I am carry on the whole way, okay? I'm not taking a break, okay? We're going to go until 10 o'clock. So from here, right, we are going to take, so the 800 is doing the clockwise at the black dot, okay? So anti-clockwise 800, and the distance is what? The distance is what? 3 plus by 2.5, 5.5. And then now I have to convert this to inches. The 12 is to convert feet to inch. Okay. And then I'm going to have minus 1640 multiplied by a distance of 2.5 multiplied by 12. And then from the dot, I have positive MAB. The whole thing is equal to 0. Okay. So therefore, MAB will be equal to 800 multiplied by 5.5 multiplied by 12. Okay, so it's equal to minus 52800, right? Plus by 1640 times 2.5 times 12, 49200. Let me do it again. 800 times 5.5 times 800 times 5.5 times 12, 5280, 1640 times 2.5 times 12, 4920. So 52800 minus 49200 is equal to minus 3600 pound inch. And when it's minus, it means the direction is wrong. Okay, so the correct direction is coming down this way. Okay, so therefore this is equal to 36 pound inch, and it's going down this way. When that's the case, the bottom bit will be in compression, the top part will be in what? Tensile. Okay, the top part will be in tensile. So now I'm going to do the analysis from right to left. Okay, now I'm going to do our analysis from right to left. Okay, analyze from right to left. So when we do right to left, the numbers will be a bit different. But the answer will be the what? Answer has to be the same. Okay. So now I'm just going to draw, we're going to analyze from right to left now. Okay. Okay, we're going to analyze from right to left. Okay, so now what we have a load over here. dy is equal to 360, and then we have a load that coming down here at 1200. Okay, and then we are going to assume MAB, and this is due to positive, okay, positive bending moment assumption. Okay, you have to have the habit when it's from left to right, the assumed direction is this way, and when it's right to left, the assumed direction is this way. Okay, that's where when you learn bending moment diagram and shear force diagram, okay, I believe 2 P08 you were taught what does it mean by positive shear, positive bending moment assumption. Is exactly what it means over here. Okay, so from here again we do summation of moment z at AB is equal to 0. So we're going to take moment from the dot that I'm drawing now. So this will be equal to what? This will be equal to 3600. So it's going anti-clockwise. 360 multiplied by 5 plus 2.5, 7.5 multiplied by 12. And then it's going to be negative 1200 multiplied by 2.5 multiplied by 12. And then it's going in a clockwise direction minus MAB. The whole thing is equal to 0. So therefore MAB will be equal to 360 times by 7.5 times by 12 is equal to 32400 minus by 1200 times by 2.5 times by 12, 3600. Okay, so this will be equal to 32400 minus 36000 is equal to minus 3600. Negative means the direction is wrong. Okay, you bring it down this way. So this is equal to 3600 pound-inch, and it's coming down in this direction. And this is where you have compression, and we have what? Tensile. So either way you do, whether it's from the left-hand side or the right hand, the answer has to be the what? Has to be the same. Okay. Now I'm not going to find your IXX and IYY. Okay, it's real straightforward. Especially this is a rectangular. Okay, sorry, a square. It's so straightforward. I'll be clear. Okay. Right. Can I go to question number 7? Are you all okay down here? Are you all fine? Andy, you okay? Makes sense? Clearer to you now? Good. Okay. Now I'm going to do question number 7. Okay, question number 7 again by no means is difficult. Okay, you just need to know your orientation. Okay, you just need to know the orientation. So I'm going to get, okay. Okay. Right. So I'm going to show, I mean, again, like what I said, you can resolve forces this way, okay, by drawing positive shear, positive bending moment, Or I've shown you another way, like down here, we did not do summation about forces. All we do is we do the moment analysis, okay? Both way works, okay? Both way the answer will be the same, okay? I find this method over here that you are seeing now, I find quicker, okay, rather than anything else, okay? Right. So we're going to solve this problem. Like always, okay, now we are going to call this our, you can label from your cross section, okay, so you can label this as your, you can call this your what, wait, let me, you can call this your X, this is your Y, and when that's the case, this is your Y, and this is your Z, okay. So this belongs to this over here, okay, whereas this belongs to here, okay. So I think the resolving of what is the axial load, what is the moment are critical down here, okay. So the centroid of interest, right, point A is where the plane is, the centroid of interest, okay, you draw a green line, this is the centroid, okay. And we know there are two forces or two moments we have. So we will have a, I will call this point A. We will have our AZ. Okay, we will have our AZ over here. And then we have our BZ. BZ, using BZ. AY. Okay. So we know our AZ will be equal to 3/5 multiplied by 500. Okay, so 3/5 it's got 300 pounds. And we know our AY is going to be what? Is going to be 4/5 times by 500. So it's 400. This is going downwards. This is going towards the right. Okay. So when this is the case, we know you see that the AZ is parallel to the green line. So this is going to cause a F, a P in the z-axis that is going to induce minus 300 pounds, and this is going to be minus pz over a, okay, or we are going to calculate stress z, okay, is equal to minus pz over a, okay, and it's minus because it's going to induce a compression. So basically, we know that we have a pz over here. Okay. Then we are going to have a moment about x. I'm going to assume moment in the x is in this direction. Why I make the assumption? Because ax is going to generate a moment in that direction. Ay, right? Ay is going to be over here. It's also going to generate a moment in that direction. So both are in the same direction. So I'm very sure that mx is in that direction. So i.e., I'm very sure that this is in compression, this is in tension, by looking at the moments. Okay, very sure about this. Okay, So when that's the case, we can calculate, okay, we can declare that this is positive. Mx, right? Again, this is rotation about x, okay? But I'm going to assume mx is going to be positive in that direction. So ay is parallel to the geometric centroid.